Hi, my name is Eric Wong. I'm the Product Marketing Manager for our USB digital IP products here at Synopsys. Today I'm here with Scott Kim from TI.
I'm Scott Kim. I'm the Business Development Manager of Connectivity Solution at TI. We're here to demonstrate the TI USB 3.0 transceiver with the Synopsys host and device controller.
We've implemented our Synopsys host and controller on a standard FPGA platform offered by Synopsys. This is the Synopsys HAPS 51 board. It has a Vertex 5 FPGA on it and standardized connectors to add boards. And in this case, this is how we connect to the TI 5 board.
These are the connectors that you can mate it to HAPS 51. And this is the actual TI USB 3.0 transceiver. As you can see, depending on the configuration, you can either make as A, standard connectors, or standard B receptacle connections. These connections are actually for USB 2, and additional bumps are provided for USB 3.0 connections. However, on the standard A receptacle, you don't have physical changes. The only change is the additional pins inside the connectors. Once you put HAPS 51 board on top of it, you can make the connection through the PCI Express Gen 2 to your PC. Now, Eric's going to walk you through a quick overview of the demo on a whiteboard.
We're here at the whiteboard for our high-level description of the demonstration. You're going to see two PC platforms and an analyzer. On the left side, this PC platform will be the USB 3 host. In the middle, we're going to have an analyzer. And on the right side, we're going to have the device. Now, those two boards that you just saw, we're going to take those two boards, we're going to connect them together, and we're going to plug them into the device PC. We're going to plug them in through a PCI Express connection. On the TI transceiver board, you saw that there is a B connector. That's the connector you use for a device-side implementation. And again, we've implemented this as a mass storage device. From the B connector, we connect into the analyzer. From the analyzer, we're going to connect into a second HAPS platform with the TI transceiver. So again, the two boards connected together into a PC using PCI Express. This has our host controller implemented on it and a standard A connector. And this side is where we initiate the transaction. So I'm going to type a command on this PC. And when we type that command in, it's going to go over here, and it's going to retrieve an HD video from the mass storage device on this side, and it's going to transfer that over to the monitor over here, the PC over here, and you'll see a 1080p, 30 frame per second high definition video pop up immediately, demonstrating the transfer speed. And then in terms of the burst, we're going to go over to the analyzer, and we're going to show that we are actually bursting USB 3.0 speeds of 250 megabytes per second and greater. So again, the demonstration is going to include these two PCs. On the left, the host controller. On the right, the device with an analyzer in the middle. We're going to go back to the lab now for the actual demonstration.
Now we're back in the Synopsys lab, and I'm going to describe the demo. This side is the Synopsys USB 3.0 host controller. In the middle, as you can see, is a test analyzer where you can monitor the real-time USB 3 traffic. And this side is the Synopsys USB 3.0 device controller. In front, we have the TI USB 3.0 transceiver board. As you can see right here is the TI USB 3.0 transceiver. In the back side is the HAPS 51 board, where FPGA version of USB 3.0 Synopsys device controller is implemented. I'm going to describe the actual connectors in more detail, and also the data path where the actual USB 3 traffic is going to move along. As you can see, on the connector side, there is a standard B receptacle and standard B connectors from the cable here. It's making through the connection through the test analyzer in the middle. As I said before, you can monitor USB traffic in real time. On here, USB 3 host controller side, you can see clearly the standard A connection with the receptacle through the cable. Now, Eric's going to take you through the actual demo.
So in running our USB 3 demo, first I'm going to describe data flow. In USB, the host manages all the data. So on this side we have the host PC, as we talked about, and we have the device, which is our mass storage device. And the host will actually manage all of the traffic. So we actually already had a movie running. We're going to close this, and then I'm going to show you how it looks when it's attached. There's a little USB logo here on this Linux box. I click on this, and you're going to see that we have a USB 3 disk. That's the Synopsys TI demonstration, and that's actually plugged in. And when I go up here and I click on it, it's going to open up a window, and you can see in this window we've got 3 movies ready to go. In this case, I'm going to click on this nature video, and when I do that, as soon as I press enter to get it going, you're going to see it's going to come up right away. So we have a 1080p 30 frame per second video. You saw that it immediately transferred that video and it starts playing it right away. To show that it's actually SuperSpeed traffic, we took a capture earlier, and in the capture you can see on the LaCroix software that it's real SuperSpeed traffic. And with the LSS analyzer, we've done a little capture of a burst, and we're getting bursts of 200 and some megabytes per second. So this actually demonstrates we're running real SuperSpeed USB traffic, and we're able to immediately run and get SuperSpeed USB speeds in our demonstration.
Thanks, Eric, for showing the demonstration. In summary, you have seen the demonstration of the TI USB 3.0 transceiver working with the Synopsys host and the device controller, transferring packets at hundreds of megabytes per second.
Scott, thanks for joining us today. To learn more about DesignWare IP and our SuperSpeed USB IP, please visit our website. Thanks for watching.